Isolated parallel, UPS system, innovative redundancy, optimized efficiency. A modern enterprise data center needs to optimize reliability with versatility and cost, allowing for the unpredictable growth rate of modern IT loads in today's commercially and environmentally focused world. The enterprise data centers of today are invariably much bigger than 10 years ago and can easily reach total power demands of 1 to even 100 megawatt. That's enough power to light more than 500,000 homes or a city the size of Miami, Florida. The goal is, therefore, to achieve maximum uptime for the data center whilst minimizing the total cost of ownership. The electrical power infrastructure, including the uninterruptible power supply, or UPS system, plays a major part in how this balance is realized. Determining the best UPS system solution is therefore critical in the early decision-making process of data center design. The UPS system design has to maximize operating efficiency, maintainability, return on investment, and of course, reliability. With ever-increasing costs of energy, that means new solutions are required that can deliver high reliability without compromising data center economics. In exploring what is traditionally available, we can see that each different system configuration to introduce redundancy and so increase reliability has limitations. For example, a system redundant scheme, whilst being concurrently maintainable and fault-tolerant, has a maximum efficiency corresponding to just 50% of installed capacity. Other solutions like isolated or distributed redundant can have higher operating efficiency, but at the expense of other factors. A simple parallel scheme where all units are connected via a common bus would seem to meet the main criteria, combining simplicity with optimized efficiency and capital cost. But such a scheme has a single point of failure where the units are paralleled. Consequently, these schemes are neither truly concurrently maintainable or fault-tolerant. So all conventional topologies have their limitations: technical, efficiency, complexity, cost, or a combination of all four. A solution that could overcome these limitations would need to have all the units share the load, have possible short-circuit currents limited, be designed such that possible failures on the load side shall not have a major influence on the non-affected loads, be designed so that in case of failure that results in a UPS shutdown, the corresponding load shall automatically be supplied by the remaining UPS units without using any switching devices. That solution is known as isolated parallel. In an isolated parallel system, each UPS directly supplies its assigned load. The connection of the UPS to the isolated parallel bus is via isolating chokes, known as IP chokes. The parallel bus is therefore called IP bus, which can be closed to a ring to further increase maintainability and fault tolerance within the system. Loading a UBT naturally creates a phase angle between the input and output voltage. This phase angle is quasi-proportional to the amount of active power taken by the load. For example, if the full load phase angle is 30 degrees, the phase angle is then 15 degrees at half load. Therefore, parallel UBT units automatically have a common phase angle between input and output. Because of this, all units now have to supply an equal amount of load. In this example, a 210% load is supported by each UPS unit carrying 70%. We'll now use a 16-module system to demonstrate both the responses and the enormous flexibility of this design under various steady-state and dynamic conditions. Under equal load conditions, for example 80% load on each UPS, we see the same phase angle across every unit, resulting in zero phase angle across the IP chokes. With no phase angle across the IP chokes, there is no power flowing through the chokes and hence around the IP bus, resulting in every UPS carrying its own load completely. Supposing now that load number 2 is reduced to 40%. In this situation, UPS number 2 is still carrying 70% of load, feeding 40% into its associated load and 30% into the IP bus. The other 15 units are each taking 2% from the IP bus, which results in a reduced power of 78% for each unit, feeding its 80% load. Once again, the load sharing is driven by the common phase angle between utility and IP bus, and the different load-dependent phase angles across each UPS, so that the sum of the phase angle across each UPS and its IP choke is equal to the common phase angle between utility and IP bus. This simple power distribution method via the IP bus applies in other scenarios, including that of a sudden UPS failure or shutdown. In this situation, the associated load is instantaneously redirected and supplied from the IP bus through the IP choke, without relying on the function of switching devices. These features and the basic IP system functionality can all be realized with just one circuit breaker at the IP choke. Enhancements, if desired, can be made to both the functionality and the maintainability by the addition of further breakers. Isolating any UPS for maintenance purposes is a simple and risk-free operation. The breaker between the load and the IP bus is closed, so that the load can be directly supported from the ring. Then, the breaker from the UPS is opened in a closed transition, which is totally secure for the load. Finally, the IP choke breaker is opened to provide complete isolation of the UPS unit. It is a simple reversal of this process to reinstate the UPS after maintenance. Isolating the IP choke is just as simple. Firstly, the IP choke breaker is opened, and then the IP bus breakers around the IP choke are operated. The IP bus remains fully functional for the remaining UPS and their loads, and the load of the isolated IP choke continues to be supported directly with UPS power. Alternatively, the system can be designed so that the load in question is transferred to the IP bus before the choke is isolated. As with all schemes, the highest risk of a short-circuit fault lies within the load distribution network downstream of the UPS. A short circuit at the load in any system will reduce the load voltage to zero, and in the case of conventional parallel redundant solutions will often cause a complete loss of load. With an isolated parallel system, healthy loads are separated from the fault as follows. Most of the fault current is provided by the directly connected UPS, and the balance by only a small contribution from each of the other UPS. Accordingly, loads connected to the other UPS are not affected. A fault on the IP bus is also possible, although much less likely. Even in this case, where the currents can be higher, the fault is restricted to levels that fall within internationally acceptable limits for IT equipment. A simple control system is employed to provide all of the functionality, because much of the load and fault handling characteristics occur naturally. A collective control for all systems is not essential, but can be added to optimize functionality. Isolated parallel schemes can be employed using either pillar rotary or diesel rotary UPS technology. The ride-through energy store can be either batteries or the pillar power bridge flywheel, and the scheme can be implemented at both low and medium voltages. The isolated parallel concept is the only solution that can offer a highly reliable, fault-tolerant, and concurrently maintainable system at the same time as delivering the highest electrical efficiency. This difference in efficiency, particularly at partial loads, brings about significant economic benefits for the data center user. When those efficiency gains are combined with the longer life and the reduced maintenance requirements of the rotary UPS, the total cost of ownership can be significantly better than other schemes and technologies. That's because the main cost factor over the life of the installation is electrical efficiency. Collectively, these benefits make the IP bus system a unique offering for the designer of any enterprise data center. They include high reliability due to the rotary UPS, the simplified control systems, and the elimination of switching devices. High efficiency due to the optimum utilization of installed UPS capacity. Concurrent maintenance by virtue of the ring concept. Fault tolerance because of natural fault limitation between critical loads. And low cost of ownership coming from electrical efficiencies, reduced maintenance, and long equipment life. Isolated parallel systems are rapidly developing all over the world as the merits are increasingly recognized. Within the first 5 years, Pillar had already installed over 250 MVA of IP bus power spread across 3 continents. If you would like to know more about what Pillar can do for your next data center, Just contact any of our internationally based companies or your local Pillar representative. Nothing protects quite like Pillar.